last time I worked on it was like a 402 and 406 or something like that. This is ancient. See it back on the manual doors.
Yeah. Where did you? Oh, there he is. Yeah, there.
Yep.
Good. Yeah, I thought it was up there somewhere. Should be a screw for it.
You need one?
Yeah.
Is it just a regular socket?
It's an M4 countersink, short one.
Countersink. I don't have any of those.
That should have been sent with it.
I might have a cover screw in mine.
It should have been shipped with it. Should be one in here anyway.
Might be one of the white boxes. There's screws in one.
Where's the other white box gone? Oh, there it is, yeah.
Is it number 4?
Yeah, here it is. I found it. It's alright, I've got it.
These are all curl screw screws.
Got it.
I use a screw screw on the AML and they explode. Up to like 1.2, 1.3. The MA6 is the manual college stuff, like Berkeley everybody has. They're around, new ones are around 700. Used ones are 150. Which one is the one? If you need help on your liners, I'm your guy.
We have another one in Bayern. It's an ancient one.
56.
56? I rebuild those down to the base plate and build them back up.
Yeah, that's ancient.
Yeah, that one has like you said. I've never used that.
Yeah, it's I can close my eyes and fix those type of thing. If you need help on them, let me know. The AML is a far superior boundary to the Susus.
I imagine the Sousa line is a little bit more accurate than this.
Yeah, like the alignment gaps I'm wrapping my head around because I'm used to like 10 to 20 microns. You know,
Yeah.
we're in the 100 micron range on these. But they have vacuum on the wafer now. So
Yeah.
It's totally different.
Yeah, well, they're doing the alignment at atmospheric pressure, aren't they?
Yeah.
So then you can use a vacuum chuck. Yeah. So yeah, we tried to use a vacuum chuck, but you can't use a vacuum chuck in a vacuum chamber.
Yeah.
You'd have to have it like 10 orders of magnitude greater vacuum to actually get any suction on it. So we tried it, it just doesn't work. We can't do it.
You'd have to go to ultra vacuum after you finish their lining and kind of center bend it, right?
Yeah.
That's the only way you can do it.
Then we looked into doing electrostatics. Then there was, like, we found one company that was willing to kind of help with that, and that was in the US, and they wanted like $2.5 million in non-recoverable engineering costs, which like Rob wasn't prepared to pay, so that never happened.
So right now, what's holding the lower
The lower wafer,
Yeah.
gravity.
And all the handling on the top one, right?
And the top one is being held by this clamp. Yeah,
And the alignment is done on the bottom or the...
yeah. So the upper one is held steady and the lower one is moved around to match.
Do I look at you?
Yes. Halfway. You wanna stay here?
So we've got two options now. We can either do some bonding, I'll show you that, or we can go through hardware and configuration and preventative maintenance and like changing heater bulbs and this kind of thing. Which would you prefer to do?
Bonding.
Bonding? Okay. Bonding it is.
So you're coming tomorrow as well?
Yeah. I need to train the super user or somebody about heater bulb changing and some mechanical things like that as well. But I guess if you're interested in bonding, then we'll do that now.
You are backup supervisor and you're a supervisor. Okay, I'm just listening about the process then. We need to have a backup supervisor for everything. It's actually a good idea.
Like all the tools now have it.
Okay, to start with, I'll demonstrate alignment because I have these demonstration wafers in there already. For doing the bonding, I've only got blank wafers with no alignment marks on them, so that we just have to kind of centralize it and then I'll hope that there's somewhere near. So I'll demonstrate alignment first because you'll want to do aligned bonding presumably.
So the line mark here on your wafers or in
The alignment marks are on these demonstration wafers, yeah. I can't bond these though.
something here on the...
Huh?
These marks on your wafer, right?
Yeah. So
Is the opening for...
So inside these apertures, there's a little crosshair in the middle of that, and then on this wafer, in a corresponding position, I've got the pattern looks like this. So I've got a cross on the upper wafer, and then 4 little squares like this on the lower. I need to kind of centralize the cross in the squares. That's kind of my target, and then it's the same on the left and the right hand side. So using that, I can adjust the theta.
Quick question. On
Yep.
our wafers, we usually have 2 alignment marks, like on the right or on the left. Where should we place them, or it doesn't?
You have
I mean,
2 on the right and 2 on the left.
I mean, we have only 2. One on the right, one on the left. You have 4 now, so...
Yeah, this is only because some of our customers have a specific setup where the wafer's kind of in this orientation with the flat on the side. So it's just for that flexibility. So
But if our flat is here, I mean, basically my question is like, how do you put the wafer so that the flat is facing this way?
yes, yeah. And then you have the marks, only 2 there is fine.
And then I have 2 over here, right?
Yeah. There's no point in having any marks on this here because there's no holes in the pattern. You won't be able to see through it anyway. So you only need the marks need to line up
I
with the
see.
holes. But we have some customers that have it in a different orientation. So my demonstration wafers have got the 4 for the flexibility. When you put the wafer on the lower platen, it's going to be inclined to slide around. So just avoid it falling off. Line the flat up. There's a little mark on the platen there to align the flat. And then we're going to try and roughly centralize the wafer within the platen. I have also got some retaining shims, retainer tooling. I can install that around the edge if you like.
I have some wafers without flat.
Okay,
Is that okay? Is there
That's
like
fine.
a notch or something here? Or?
absolutely fine, doesn't matter. They won't be compatible with our clamping, like lower wafer clamping mechanism, but it's fine, you don't need the clamping mechanism. Personally, I find it annoying, it gets in the way when you're trying to load the wafer, so I don't use it, but I can install it and we can use it if you wish. But yeah, for a wafer without a flat, it won't fit. So that's fine, you just have to take that tool off. Okay. The upper one I've already loaded, it's clamped in there nicely. Pop these bolts in. Okay. I'm going to demonstrate it in manual mode. So I'm just going to call this run an alignment demo. Right. So as I have a glass wafer in the top, I can use visible illumination, which is what I'm going to do.
Which
Anything
one
else?
is referred to the top wafer and to the left? So
Sorry.
you have two windows there. One is
Yeah.
referred to the bottom wafer and one is to the top, right?
No.
What's it?
The left-hand
Oh,
window is the
okay.
left-hand camera, and the right window is the right
Okay,
camera.
got it.
Right. So the first thing we need to do is focus on the upper wafer. I like to have a large separation between the wafers when I do this, because then I know that whatever I see is going to be the upper wafer. I'm not going to accidentally focus on the lower wafer and then get confused. There is an easy way to check, so we bring that into focus. If we just move the manipulator in either X or Y direction, and we don't see any movement here, that means we're focused on the upper wafer. If we see movement, it means we're focused on the lower wafer. So I've got coarse focusing with the rack and pinion system here. Then I have fine focusing with these sliders behind the cameras, some little silver knobs. So focus those as well as possible. Then we've got X and Y translation with the cameras to try and centralize these marks within the window. So now I'm going to move the camera down a little bit and bring the lower platen up into focus. Hopefully we'll find something to focus on, some piece of dirt, or if we're lucky, some alignment marks.
So you're basically looking for a state and you can see both, right?
Yes, yeah. So at the moment we're still 2 millimeters separated. When we get the separation down to sort of 0.2, 0.3 of a millimeter, then we'll be able to see both at the same time. But for now, I was just trying to avoid crashing the wafers. So at the moment, I can see that let me just sharpen up that image a bit. The theta rotation is out, so the right-hand side mark is lower than the left, which means I need to rotate the wafer counterclockwise. So I can do that just by pushing left. I'm just going to move that until I have these two roughly level on the screen. Then I know that I've got the rotation approximately correct. Now I can still see the sort of hazing of the upper mark, so I can move that roughly. I can use X and Y translations to move these roughly into the right place now. So I've got two sets of marks, there's a large set and a smaller set. The small set is best for doing manual alignment that we're doing at the moment. The larger set is for systems that have optional automatic alignment. Okay, so now I've got the lower wafer roughly in the correct position. I'm going to focus back onto the upper one. Just going to get a bit better contrast there. I'm going to bring the lower wafer up until we come
Can you
into
just
proximity.
input in this field, I guess 0.2 millimeter undertone?
Yes, you can, but at the moment I've set the 0 position under vacuum, which is going to be slightly different because at the moment it's under atmospheric pressure, and I haven't bothered to pump it down because we'll just be stood around here waiting for 15 minutes for it to pump down. So I've just sort of taken a bit of a shortcut there. So to avoid crashing it, I'm going to just do it manually. But yes, you can, if you like, just put in here, request a separation value. So we can say 0.5. I'm confident that that should be fine. Control the separation. So yeah, we can see it's coming close, but it's not quite there yet. Annoyingly, somewhat annoyingly, when the separation control is active, we can't move the manipulator. So we have to stop the motors, stop the separation control then before we can make any further translations with the X and Y. So in the last little bit, we are going to need to do manually under step control. Right, I'm going to change the steps down from 100 microns to 10 microns now. So I've got a bit slower, a bit more control. For some reason on this right hand side camera there's a slight mismatch in the focus between the up and low, and I think that's because the lower platen is slightly off level perhaps at the moment. We have to look into that. But that's kind of a known, that's quite common. So we just have to kind of focus that as best we can on both. So at the moment we can see I've got this marks fairly well aligned around the cross, and this one is off, so I'm still slightly out in my theta. I need to take that counterclockwise now. Okay, now my theta step is too large. I need to change that to 0.01 rather than 0.05. Some finer control. Okay, so there we can see I've got these two squares kind of sat on top of the cross, and these two are also sat on top, so they're level now. So now I can use Y just to move those back up. And then we have pretty good alignment there. We can zoom in. At this point it's kind of you need to be careful not to kind of move around too much, otherwise we're going to have problems. So this is where it can be helpful to draw a square, like match the sides of that to the cross. So we can see there's actually a slight gap there, so I need to move it up a little bit further. Now 10 microns is probably too big of a step, so I'm going to change that down to 2. Quite good. This needs to focus a bit better. Yeah, that's actually a really bad mismatch in focus there.
Is it better to start with leveling the two planets
Yes, yeah, but that's what I'm going to show you later. That's part of the kind of mechanical setup. So we'll just go through the bonding stage of things at the moment.
Also, it's not going to make any problem with the bonding if they're not level.
No, because the mismatch is probably only from one side to the other, like 10 microns or something. It's probably not too bad. But yeah, we can check it. Maybe before we do an actual bond, we can check it if you like. This is another reason why if this happens, I can focus on the cross, draw the square. Now I know the square's in the right place, I can refocus onto these lower marks and kind of move them into the square, because the square hasn't moved. Yeah, so I think that's pretty much as accurate of an alignment as I can do with the wobble happening there. So, to zoom out again, hold shift and click. Oops. There's a hand there for panning the image around. So that's quite accurate alignment now. So now I'm going to ruin it and let you guys have a go. Just going to change the position of everything a little bit. So, okay, who wants to have a go?